I am Professor Padma Reddy, working in the Department of Computer Science and Engineering, Sai Vidya Institute of Technology, Bangalore. Today's class I am going to concentrate on structures and unions. Before that, let me ask some questions to you. Now, can you tell me what is a derived data type? What is a derived data type? Before that, can you tell me what are basic data types in C language? The basic data types in C language are int, float, char, double, etc. and so on. Once we know what are the basic data types, let us see what is the definition of a derived data type. The data types that are derived from basic data types such as int, float, char, double, etc. we call them as the derived data types. The various derived data types that are available in C language are: first one we have arrays, second one we have pointers, third one we have enumerated data type, fourth one we have structures, and then we have unions and so on. Now we know the data types that are derived from basic data types such as int, float, char are called what? Derived data types. In the previous sessions we have seen arrays, we have seen pointers, we have seen enumerated data types. Now let me concentrate on structures and unions. Before entering into the concept of structure, let me concentrate on one keyword by name typedef. Let me explain the typedef with the syntax with example. For example, we have subject 1, subject 2, subject 3. How many variables are there? 3 variables are there, and I want to use those 3 variables to store marks of 3 subjects. So when I say marks, marks is of type what? Integer. So let me define subject 1, subject 2 and subject 3 as what? Integer. Now what is the data type we have used here? Int. Instead of using the data type int, if we had the data type by name marks, it would have been better. It is easy for us to say that subject 1, subject 2 and subject 3 are of type what? Marks. But unfortunately we don't have basic data types such as marks. So what we do? Earlier what we had? Int. That int now should be replaced by what? Marks. So that can be done by writing int. Int should be followed by what? Marks. But remember, that can be done by using typedef. Typedef is a keyword. Using this keyword, wherever marks is declared and that marks is replaced by of type what? Integer. Another example, suppose I want S1, S2, S3. 3 variables are used to store ID numbers of 3 subjects. So normally what is ID? ID may be of type integer. So let me write int S1, S2, S3. But again, by looking at this declaration, it is very difficult for us to say what values are available in S1, S2 and S3. We can simply say integer values are available. But instead of that, if I replace this int keyword with ID number, by looking at this, we can clearly know that S1, S2 and S3, 3 variables contains what? ID number. Earlier what we had? Int. That int should be replaced with what? ID number. So here I write int can be what? ID number. So here wherever marks are there and wherever ID number is there, it will be replaced with what now? Int. Okay. Now here marks and ID number, we call them as user defined data types. So user defined data types such as marks, ID number can be obtained using the keyword typedef. Now let us see what is the definition of typedef. What is typedef? The typedef is a keyword that allows the programmer to create a new data type name for the already existing data type. What is already existing data type? Int. Instead of giving the name, instead of using int, we can replace with what? Marks, or we can replace with what? ID number. So I can give another example. Suppose I said type def float followed by amount. It means wherever amount is used in the program, that amount is actually of type what? Float. But wherever float is there, I am replacing with what now? Amount. So the purpose of type def is to give an alternate meaningful name for any data type. Now, what is the definition? The type def is a keyword that allows the programmer to create a new data type name for an already existing data type. So, the process of creating a new data type name for any data type is called what? Type definition. The syntax is shown below. How to use a type def? Look at the syntax. First, we use the keyword type def. It has to be followed by either float or int. Now tell me, what is this float or int? It is a data type in general. So here I write name1, comma name2 and so on. In this specific example, what is name? Amount. It can be marks. It can be ID number also. Now we know what is a type def and what is the syntax of a type def and how to use a type def. This is the first example and this is the second example. Now let us see what are the user defined data types. Now if you observe amount, marks and ID number, they are not the data built-in data types, they are not the primitive data types which are available, they are user defined data type that has been created using the keyword type def. So what is the definition of user defined data type? The new data type names such as amount, marks and ID number, the new data type names that are defined by the user using already existing data types such as int, float and so on with the help of keyword type def are called user defined data types. Now here if you observe amount, marks and ID number, they are user defined data types. Now let us write one small program which uses the user defined data type. I want to compute simple interest. So to compute simple interest, first of all we should input the value for P, T and R, principal amount, time and rate of interest. To read the data from the keyboard, can you tell me what statement I have to use? I have to use scanf. How many values I have to read from the keyboard? 3 values, all are of type float. So I write percentage of, close double quote, comma, ampersand P, ampersand T and ampersand R. End with semicolon. Here ampersand represent address. P stands for principal amount, T stands for time, R stands for rate of interest. Normally before scanf what we use? Printf. I write printf, enter principal amount, time and rate of interest. Now once we know what is the value of P, what is the value of T and what is the value of R, we can compute simple interest. Can you tell me what is the formula to be used to compute simple interest? Simple interest equal to what? P into T into R. PTR divided by what? 100. So this using this expression we can compute simple interest and the result will be available in which variable here? SI. Now let us display the value of the result stored in the variable SI. So to display the result SI, tell me what statement I have to use here? Printf. I write printf simple interest is equal to percentage of, close double quote, comma, what? SI. Now our program is over, but only thing is whatever variables are used in the program, all those variables have to be declared before they are used. Now tell me what are all the variables? P stands for amount, P is principal amount, SI is simple interest, it is also amount only. So here I say P and SI are of type what? Float. What about T? T is time. time stands for, time may be 1.5 years and so on. What is that 1.5? Float. So here I declare, what about P? P, principal amount and simple interest are what? Amounts. Next, what is T? T is of type float. And remember, T stands for what? Time in years. Next, what is the next variable we have? R. Tell me what is R? Rate of interest. It can be 1.5, 1.6, 1.7 and so on. But remember, it is a floating point number. Floating point value has to be stored in the variable R. So for that reason, I declare R is of type float. So here I write what is R stands for? Rate of interest. Now, all these statements, whatever you have written so far, all these statements must be enclosed within braces. So, here I write void followed by main followed by empty parenthesis. Now, the declaration of the printf and scanf function will be available in one header file by name stdio.h. So, go here and write hash include stdio.h. Don't be under the impression that the printf and scanf functions are available in stdio.h. It is not true. The function printf and scanf are available in the library. The declaration of printf and scanf is available in stdio.h. So this is the complete program to compute simple interest. But here, instead of writing float, if I read this float p, si, it does not make any sense. I cannot understand what value is available in the variable p and si. So what I do? Instead of writing float here, I replace with what now? Amount. Now I can easily say that P and Si contains what? Amount. So in place of what? In place of float, we wrote amount. So here in place of float, we wrote amount. So what is the keyword I should use? Type def. It means it is the instruction given to the compiler. It means wherever amount is there, it will be replaced with what? Float. Similarly, T stands for what? T is of type what? Float. Instead of saying float, if I say time, so in place of float, what we can write? Time. Similarly, this float can be replaced with what? Rate. So here I write rate. Remember, this amount, time and rate, they are not the data types available in C language. They are the data type names which have been created here using the keyword type def. So this is the advantage of using type definition such as type definition names such as amount, time and rate, because we can easily understand what values are stored in the variables. I hope you understood how to use type def and what is the advantage of using type def. Now the question is, now let us try to enter into structures. Before giving the definition of a structure, let us see when we use structures. Now, point number 1, we know that an array is a collection of what? An array is collection of similar type of data items. For example, we may have an array of integers, an array of floating point numbers, an array of characters and so on. So, array is always collection of similar data types. It is not a collection of dissimilar data types. Point number 2, the ordinary variables and arrays can handle variety of situations. But in real world, we can deal with entities that are collection of dissimilar data types, or that may be collection of similar data types. Suppose we want to have the following information related to a student. I want to store the name of the student and then the marks scored by a student and the average marks scored by a student. Remember, name of the student is of type string, marks is of type what? Integer, and average marks is of type float. So, it is a collection of dissimilar data types. One is a string, another integer and another is a floating point number. Since the above information is a collection of dissimilar data types, arrays cannot be used. No doubt, arrays can be used to store the name of a student. Okay, but array cannot be used to store the student name, marks and average marks. So, since the above information is a collection of dissimilar data types, arrays cannot be used. And in this situation, the structures are used. So, when structures are used, whenever we want to have a collection of similar or dissimilar data types that are logically related, then we go for structures. So, whenever we want to have a collection of similar or dissimilar data items that are logically related, then we use structures. I hope we understood when we use a structure. Now let us think of what is a structure and what is the definition of a structure. First, let me explain what is a structure using the syntax. Member 1, member 2 and so on, member n, all are the identifiers. If I say member 1 is of type 1, now we say member 1 is a variable of type 1. Similarly, member 2 is a variable of type 2 and so on. Here, name of the student can be member 1. So, what is the student name consists of? It consists of array of characters. Now tell me how you define a name which consists of only characters. I can write something like this, name of 20. A name can have maximum of how many characters here? 20 characters, and we say they are of type what? Character. So, I use the keyword char. Then, marks scored by a student. It is of type what? Integer. Tell me how you declare a variable marks to store integer value. That can be done by writing marks. Marks should be declared of type what? Integer. Similarly, I want to store average marks scored by a student. Definitely it is a floating point number. Now tell me how you declare. Here I can write average. Average is of type what? Float. So if you observe, name is of type character, marks is of type integer, average is of type what? Float. So we have a collection. When we have a collection of dissimilar data types but logically related, this is the information related to a student. Now, all those informations I am going to store within the braces because I want to treat it as a single entity. Whenever I want to treat as a single entity, enclose them within braces like this and end with a semicolon. And here also we have to enclose all this information within the braces ending with what here? Semicolon. This is the rule, syntax. Next, here we use the keyword struct, struct. Here also we have to use the keyword struct. Now, can you tell me what is the definition of a structure? A structure is a collection of various logically related data items. It is a collection of logically related data items. Name, marks and average, they are related to student. So, a structure is a collection of various logically related data items. So, these are the data items. The data items may be of the same data type. Here we have used different data types. It may be same also. In this example, it is different. So, the data items may be of the same data type or dissimilar data types grouped together as a single entity. All these data items of dissimilar data types are grouped as a single entity using the keyword struct. The data items inside the structure. What are the data items inside the structure? Name, marks and average. We call them as the members of a structure or fields of a structure. So, what is the name given for these members? They are called members of a structure or fields of a structure. So, here I write the data items inside the structure are defined as variables. These are all defined as variables and are called what? Members of the structure. They are also called fields of the structure. So, a structure is identified using the keyword struct. So, this structure is identified by the keyword struct. A structure is a derived data type in C language. It is derived from basic data types such as char, int and float. So, we say a structure is a derived data type. I hope you understood what is a structure. For example, a student information to be grouped may consist of the first one. What is the first one? Name of the student. What is the second one? Marks scored. And third one is average marks scored. So, here tell me what is this struct? Struct is a keyword. It is followed by member 1, member 2 and so on. Here member 1, member 2 members, they are the variables. They are the variables defined inside the structure. And these variables defined inside the structure are called members of the structure, and they are also called fields of the structure. Remember, semicolon is must at the end. After closing the brace, you have to end with semicolon. It is compulsorily. When I say syntax, it is a rule. You have to put semicolon. You should never ask why you have to put semicolon. It is a rule. Rules cannot be questioned. You have to simply follow the rules. So, put semicolon here. And finally, memory is not reserved when we define a structure. The moment we define a structure, look here, a structure is defined consisting of student name, marks scored by the student and average. If we define a structure like this, memory will not be allocated. Now, let us see what are the different ways of defining a structure. We know what is a structure, when to use a structure. Now, let us see what are the different ways of defining structures. A structure can be defined using 3 different ways. Point number 1, tagged structure. This tagged structure, it is also called named structure. A name is associated with structure. A tag name is associated with the structure. That is the reason we call it as a tagged structure. And the second one is tagless. There is no tag. That means there is no name associated with the structure. So, we say it is a nameless structure or unnamed structure. And finally, we have type defined structure. This type defined structure here, it can be named structure or it can be nameless structure also. We see each method one by one. Now, first let us concentrate on what is a tagged structure and how to define a tagged structure. In the structure definition, look at this. Here we have member 1, member 2 and so on. This is type 1, type 2 and so on. All those things must be enclosed within braces and it should end with semicolon. Here I use the keyword struct. So, here name is an array of what? Character. Marks is of type integer. Average is of type what? Float. All these things are related to a student. So, they are logically related. So, enclose them within the braces, and here as I use the keyword struct, here also use the keyword struct. So, in the structure definition, you can take either this specific example like this or a generalized structure like this. So, in the structure definition, the keyword struct can be followed by an identifier. Here it has to be followed by an identifier. So, what is an identifier? I write here student. So, in the structure definition, the keyword struct can be followed by an identifier. This identifier is called tag name. So, this identifier is called what? Tag name. In general, I write struct followed by what here? Tag name. So, this identifier is called tag name. The structure definition associated with the tag name, this is the structure associated with what? Tag name, okay, is called the tagged structure, or it is also called named structure. Whenever a name or tag is associated with a structure like this, we call it as a tagged structure or named structure. The syntax of tagged structure is shown below. This is the syntax and this is the example. I hope we understood how to use a tagged structure. Now, Let us see what is a structure declaration. Remember, this is a tagged structure only, and what is structure declaration? By defining a structure, memory will not be reserved for the members of a structure. Here we have defined a structure, but remember, compiler will not allocate memory for this structure. Point number 2 is memory will be allocated for members of a structure when the structure definition is associated with variables. Whenever this structure definition is associated with variables, then only memory is allocated. So, the syntax is, you write this header, this is called header, structure header, this is a structure body. Take that structure header as it is and write here struct tag name. It has to be followed by v1, v2, v3 and so on. These are all what? Variables. Now, all variables should be separated with a comma, and it must end with what? Semicolon. Final variable must end with semicolon. This we call it as type declaration, or declaring the type of the variables, or it's called variable declaration. In this example, okay, I write struct student here. It has to be followed by a variable, say such as a CSE, comma ISC, comma MEC and so on. So, for the sake of explanation purpose, I use only one variable. So, CSE is a variable of type what? Struct student. How the struct student is defined? This is how the struct student is defined. Point number 3 is the process of reserving the space for the members of a structure is called structure declaration. So, this is the structure declaration, and this portion is a structure definition. I repeat, this is a structure definition and this is a structure declaration. Now, what about this? This portion which I am highlighting is called structure definition, and this portion here we call it as what? Structure declaration. Now, we know what is tagged structure and how to declare a variable of type structure. Now, let us see how and when memory is allocated for a structure. A block of memory is allocated separately for every structure variable. The moment you declare a variable like this, a block of memory is allocated for every structure variable. Now, a block of memory is allocated. What is a structure variable here? CSE. The name given to this block, I will call it as what? CSE. Next, point number 2 is the memory for each member of a structure is allocated. So, how many members are there? 3 members are there. So, separately memory will be allocated for these 3 members in the order specified within the braces. What is the first one? Name, second one marks, third one average. In this order only memory will be allocated inside this block. So, what is the first one we have? Name. Name is an array of how many characters? 10 characters. So, we reserve how many memory locations? 10 memory locations, ranging from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, totally how many memory locations have been reserved? 10 memory locations have been reserved for the variable name. Now tell me what is second one? Marks. Now tell me marks is of type what? Integer. What is the size of integer? It may be 2 bytes, it may be 4 bytes, it may be 8 bytes. It all depends on which compiler we are using. Suppose I am using a compiler consisting of integer whose size is 2 bytes. In that case, 2 bytes of memory will be allocated for the variable what? Marks. Next, what is the next member you have? Average. For average also memory will be allocated. I will assume that in the compiler what I am using, the size of a float is 4 bytes. So, how many bytes of memory location? How many bytes of memory is reserved? 4 bytes. 1, 2, 3, 4. So, for name 10 bytes are reserved, for marks 2 bytes are reserved, and for average how many bytes are reserved? 4 bytes are reserved. So the size of a block is the sum of individual sizes of all members of the structure. So what is the size of a name? 10. What is the size of this? 2. So 10 plus 2 is how much? 14. 12. 10 plus 2 is 12. 12 plus 4 how much? 16. So totally size of this block is 16 bytes. So I hope you understood how the memory is allocated and when the memory is allocated. If you define a structure like this, memory will not be allocated, but if this structure definition is associated with a variable like this, memory will be allocated in the order in which the members are defined. Now we know what is a tagged structure. Now let us look into what is the tagless or unnamed structure. In the structure definition, this is the structure definition. For example, name is character, marks is of type integer, average is of type float. All these members I enclose within the braces, and here I use the keyword struct. This is the structure definition. In the structure definition, the keyword struct is not followed by an identifier. Earlier if you wrote, I wrote what? Student. Now I am not going to write student. I simply leave this blank. So there is no name. There is no tag name. That means there is no tag associated with the structure. Earlier it was tag name. Now I am removing this tag name. So there is no tag associated with the structure. So the structure definition, this is the structure definition without any tag name. So the structure definition without tag name is called tagless structure or unnamed structure or nameless structure. There is no name for this. If I write student here, there is a name for this structure, but I have not written anything, so it is a nameless or tagless structure. The syntax of tagless structure or unnamed structure is shown below. This is syntax and this is the example. Similarly here, now how to declare? By defining a structure like this, we know that memory will not be reserved for the members of a structure. Memory will be allocated for members of a structure when the structure definition is associated with variables. Now, earlier we have used tagged structure, now we are using tagless structure. The process of reserving the space for members of a structure is called structure declaration. So here what we do is, whenever we don't have any tag name here, it is compulsory that immediately after the brace don't end with a semicolon. Instead you have to declare the variables here only, v1 comma v2 and so on up to vn, and finally end with a semicolon. Similarly here, this semicolon must be replaced with what? A variable, say CSE. If you want one more variable, say make you write MECH, comma civil CV and so on. Now, how and when memory is allocated? A block of memory is allocated separately for every structure variable. A block of memory is allocated for the variable CSE. Next, the memory for each member of a structure is allocated in the order specified within the braces. So first memory has to be allocated for name, followed by marks, followed by what? Average. So here what should I write? Name. How many bytes of memory is allocated? 10 bytes of memory will be allocated. Starting from where? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. And then memory has to be reserved for what? Marks. How many bytes? 2 bytes. Assuming integer takes 2 bytes. Then it has to be followed by average. For average, how many bytes? 4 bytes. Assuming floating point number takes how many bytes? 4 bytes. So the size of a block is sum of sizes of individual members of the structure. So here we have 10 bytes. 10 plus 2, 12. 12 plus 4, 16. So totally 16 bytes are allocated for the variable CSE. Now we have seen what is tagged structure, tagless structure. Now we see what is type defined structure. In the structure definition, this is the structure definition. Name is of type character, marks is of type integer, average is of type what? Float. So here we use the keyword struct. Remember, there is no tag name here. So what it is? Tagless structure. So in the structure definition, the keyword struct is not followed by an identifier. It is not followed by an identifier. So it is a type tagless structure. If I write a tag name here, it becomes a tagged structure. So there is no student. I don't write student here. It is a type of a tagless structure. Here we don't have tag name. So it is tagless structure. So here also we don't have tag name. Don't write tag name here. But it is preceded by the keyword type def. So here you have to write the keyword type def. Here also you have to write the keyword type def. Now, whenever this structure is associated with the keyword type def, we call this as what now? Type defined structure. So, the structure definition with the keyword type def is called type defined structure. It is an example for type defined structure. The type defined structure must be followed by an identifier. So here don't end with semicolon here, but remember instead it must be followed by an identifier. So ending with what? Semicolon. An identifier must end with semicolon here. So I write type ID end with semicolon. Here also I write student end with semicolon. Remember, student is not a variable. Student is the type derived from this. So student is of type what? This structure consisting of how many fields? 3 fields. One is name, marks and average. So this is only the definition. Still we have not allocated the memory because we have not associated any variable with this structure. So this identifier acts as a data type. This student acts as a data type. Using this type defined structure, we can declare variables. This is the syntax of defining a type defined structure, and this is the example. Now the question is, what is structure declaration and how to declare variables? By defining a structure, memory will not be reserved for the members of a structure. Memory will not be reserved as I told. Memory will be allocated for members of a structure when the structure definition is associated with variables. So here the process of reserving the space for members of a structure is called the structure declaration. Now here we write type ID and followed by V1, V2 and so on up to Vn. So how many variables are there? N variables are there. All are of type what? Type ID. Similarly here I use one variable by name CSC. CSC is of type what? Student. Remember, student is not basic data type such as int, float, char, double and so on. It is derived using the basic data types. So we call the student as a derived data type. Now let us see what are the different methods using which structure variables can be defined using type def. Using the type defined structure, a structure variable can be declared as shown below. Here we don't have tag name, it is tagless, type defined. This is type defined structure only, but there is no tag associated with this. Or here if you remember, here after struct we don't have any tag name, but here after struct what we have? Tag name. What is the tag name here? Student. This is a tagged structure. So here how to define a variable? I write struct student is of type struct student is the basic data type, derived data type, and CSC is a variable. CSC is a variable of type what now? Struct student. So this is tagged structure. But what I do here is, let me use one more variable. Say I write ISC. IAC is of type what? Struct student. CAC is also of type what? Struct student. Both are derived from this structure. So we say structure is a derived data type. Now, instead of writing struct student each time, I replace struct student with what? Capital letter STUDENT. In place of struct student, what we wrote here? Capital letter student. So before that, what we use? Type defined structure. So wherever struct student is there, here also struct student is there, it can be replaced by what now? Student. So using a tagged structure, a structure variable can be declared as shown below. This is method 1, this is method 2. Both are tagged structure, both are type defined structures. So whenever a structure is associated with type def, we call it as what? Type defined structure. Now we know what are the different methods using which a structure variable can be defined using the keyword type def. In place of, so here tag name is used. Now let us see how and when the memory is allocated for a structure. This already explained. A block of memory is allocated. Now I am talking about type defined structure. Whether it is type defined or tagged structure or tagless structure, the memory allocated in this manner only. A block of memory is allocated separately for every structure variable. So a block of memory is allocated. What is the name given for this block here? CAC. Name given for this block is CAC. The memory for each member of a structure is allocated in the order specified within the braces. So name, how many bytes? 10 bytes ranging from 0 to 9. Then for marks 2 bytes. Average 4 bytes. So the size of block is the sum of individual sizes of all members of a structure. So together it will be how many bytes? 16 bytes. Now we know what is a tagged structure, what is a tagless structure, and what is a type defined structure. Now let us see what is initialization, how to initialize the members of a structure. Before that, let me see what is variable initialization. Now look here, if I say int a, what will happen? 2 bytes of memory will be allocated, say starting from location say 1000. The memory location, this memory location has the address 1000 and this has the address 1001. The entire memory location, 2 bytes of memory location, the name given is what? A. So a is a variable of type what? Integer. Now nothing is stored here, junk value is stored. So the variables are not initialized when they are defined. If you define a variable like this, memory will be allocated, but the memory is not initialized. Hence they contain garbage values and they have to be initialized with valid data. So when memory is allocated, garbage value will be there. So let us try to initialize with valid data. I may write like this, int a equal to 24. Now tell me what will happen after memory is allocated in this named memory location a, what has to be stored? 24 is stored. Now the junk value is replaced with what now? 24. The method of giving initial values to variables when they are defined like this or before they are processed is called variable initialization. So this is the variable initialization. It is part of the declaration only. So what is a variable initialization? The variables are not initialized when they are defined. Hence they contain garbage values and they have to be initialized with valid data. The method of giving initial values to variables when they are defined or before they are processed is called variable initialization. For example, this one. Now the question is how arrays are initialized. Look at this. int a of 5 is equal to 10, 20, 30, 40, 50. Now tell me what will happen. Compiler will allocate how many memory locations? 5 memory locations ranging from A0 to A4. Each memory location contains how many bytes? 2 bytes, because size of integer is 2 bytes. So this memory location is identified by A0, this is A1, this is A2, this is A3, and this is A4. So in these locations, what is stored? 10, 20, 30, 40, 50 is stored. So here 10, 20, 30, 40 and 50. This is how the arrays are initialized. Now let us see how to initialize these structures. The syntax of initializing structure variables is similar to that of arrays. That is, all the data items will be enclosed within braces. All the data items must be enclosed within braces. That is, left brace and right brace, and are separated by commas. The syntax is shown below. So here we write the structure followed by what? Tag name, followed by variable equal to v1, v2, v3 and so on up to vn. Enclose all these variables within the braces like this and end with a semicolon. This is the syntax to initialize the members of a structure. Now let us take one example. Now tell me, what is this? There is no tag associated with this structure, so we say it is a tagless structure. Whenever there is a tagless structure, here we have to write the variable, and that variable must end with what? Semicolon. Now memory will be allocated. For name, how many bytes? 10 bytes. For marks, how many bytes? 2 bytes. And for average, how many bytes? 4 bytes. And this is the block. What is the name given for that block? CSC. How to initialize? Look at this. I write CSC is equal to, if I end with semicolon, it is not initialized. The members of a structure are not initialized. But if I write CSC is equal to, within braces, I write RAM 25 and 24.5. How many data are there? 3 data items are there. All those data items I enclose within braces and end with a semicolon. Now see what will happen here. RAM will be copied into the name location. It is a string. We know that string always ends with what? Null character. So here I write /0. And this 25 will be copied into marks field. And this 24.5 will be copied into average fields. Now we know how to initialize the members of a structure, but remember what structure we have used? Tagless structure or unnamed structure or nameless structure. So we have initialized only one variable. Suppose I write, instead of writing CSC, I write A comma B. Now let us see how the memory is allocated. How many variables are there now? 2 variables are there. So 2 sets of memory locations will be allocated. This is for, this block is for the first variable. What is the first variable? A. So here I write A. For another block, for the variable B consisting of name, marks and average, another block of memory is allocated. What is the name given for this block? B. Now remember, we write A comma B equal to something. Remember, if you observe, only the variable B is initialized, the variable A is not initialized. So junk values are there in this in these memory locations. So here what will happen? RAM will be copied here and it ends with what? Null character. And then what you have? 25 will be copied here. And then 24.5 will be copied here. So this is how the structure or the nameless structures are initialized. Now look at this. Here we have again, if I want to initialize both variables, then you have to write A is equal to something like this and B is equal to something like this. Now what will happen? Memory will be allocated for what? A. Another sets of memory locations will be allocated for B also. What is the name given for this memory location? A. Now what happened here? Ram will be copied here. This string ends with what? Null character. This 25 will be copied here, and then 24.5 will be copied here. But remember, there is another variable b. So what will happen? For name 10 bytes, for marks how many bytes? 2 bytes, and for average how many bytes? 4 bytes. So what is the name given for this memory location? This is b. Now what happened here? Sam will be copied into this memory location. It ends with what? Null character. 24 will be copied into this memory location, and this 23.5 will be copied into this memory location. I hope you understood how to initialize more than one variable using the tagless structure also. Now let us I think we stop at this point, and let me concentrate on how to initialize the tagged structures in the next session. Thank you.